Errors is our new topic we are going to see in this lesson, but please don't forget to subscribe to the channel. Now, errors, of course, deals with something being made deviating from the exact thing. So, an error is a difference between an absolute and exact value and an approximate value. If exact value is x and an approximate value is small x, error is given by the exact minus the approximate. So our exact is x, then our approximate is small x. So what we get is the error. In simple terms, it's the deviation from the exact value. That's something either below or above. That deviation is what we call the error. So that's types of error. We have random errors. These occur due to human errors or machine errors. And such errors can't be treated numerically. So when a machine fails to do something, that error that is made is not going to be treated numerically, or it's not going to be used mathematically. Then rounding off errors, I think everyone knows how to round off at this stage. Rounding off something, it means that you are giving something similar to what would have been the answer. So there you are making a small error. So that's what we call the result of simply approximating the value of a number, e.g. I think everyone here knows what a value is. If they approximate to this, now there's a small error made to two decimal places because you're not giving the full thing, you're just giving it to a certain number of decimal places. Then root 2, this rational function. The rational function, now, you know when you do this, it will be for significant figures, but we are just approximating. The whole thing is too long. Remember, this is not terminating. You can never come to this number. So we just give it for significant figures. So there, we are making an error of not giving the exact number, but giving a number similar small to this. Truncation errors, these occur when an infinite number is terminated at a point. Now, there's a difference when we are rounding off and when we are truncating. When we are truncating, you look at this number, 3.9345. If you are truncating at 4, you don't even bring, like, you know, when we are rounding off, we add a number. If this one is above 5, is a better we put 5. But in truncation, you just stop there at that point. You don't add anything. So here you start, you are making an error. This number and this, there is a small difference. So there we said that's called a truncation error. Truncation and rounding off errors are sometimes realized as rounding errors. Common terms used in errors. A, absolute error. This is a modulus error, simply got by getting an error magnitude. So if we have x be an error in x, absolute error, get the modulus of that thing. In simple terms, absolute errors are always positive. Then relative errors, this is a ratio of an absolute error to exact value. So relative error is given the value of the error divided by the exact value. If you don't have the exact value, sometimes they say you give it to, you use the other approximate value. Anyway, the percentage error, this is the relative error expressed as a percentage. E.g., percentage errors, you get the absolute error, the relative error, absolute error over the exact, then you get the relative, then times 100. That's how you get the percentage error. Let us see some examples here. A student made a mistake of multiplying this and he got 25. Calculate the absolute error. You know, to calculate any error, you need to be having the exact and then the approximate. So this is going to be the approximate value, but what is the exact? So to exact it in our solution, now we come to the exact value. Our exact value is when we multiply this property. 5.6 times 4.5. What do we get? When you press that on the calculator, you get 5.6 times 4.5. You get 25.2. So that's the exact value. Our approximate value is this. Our approx value is the one that and this guy got as 25. So that is approximated to the answer. Then our error is going to be now, we say exact minus the approximate. So it will be the exact is 25.2 minus the approximate. And so this one is going to give you 0.2. As simple as. So that is our error. Now, to get the absolute error is going to be, we say we get the error in the modulus as you see the absolute error. You just get the modulus of that error, and it's already positive, which means the same. If it's negative, now this will be positive. When we come now to our relative error, we shall get 0.2 over the exact. Our exact was 25.2. That is what we call the relative error. As you see, the error over the exact. Then you get that. So here, I'm getting this as 0.0079. Then we come to the percentage error. We get the relative error and use 100. So our percentage error we express the relative error as a percentage. So this will be now 0.0079 times 100, which will be, when you get that, be 0. When you shift this one decimal place, two decimal places, so we have 0.799%. So that's how we get our errors in simple terms. That's it. That's it, members. Now we are going to see some examples of truncating, the difference between truncating and then rounding off. See you there.